Okay, so again, let me just check if you guys are already in front of your computers. So just give me a thumbs up. Okay, very good. So any questions so far before we continue for the I sub 3? Okay, so I guess none. All right, so let us continue now. So one thing that you guys need to know, okay, so for this VD, since this is our reference voltage, okay, this is the node that is connected to our negative sources, okay, or as to make it simple, this one is our ground, and a ground has a value of equal to 0. Okay, it's always 0 volts, so there is no potential voltage at node D. So we can use the law of Kirchhoff's right here. So if we have 10 volts right here, so some of them will go here, and then go here. But after passing them, okay, and then going back to the negative source, it's already equal to 0. Okay, so if you want to get the 10 volts, so you have to get the value of this one, value of this one, and then the value of this one. But there is never a value at this node or at this point already. Okay, so VD is already equal to 0. So in here, the same concept. So of course, as we can already see, we have a small voltage right here, okay, that is passing through, coming from VE and then VC. But at VD, we have 0. So we can already say that VB minus VD divided by R3. Okay, using this rule right here. So minus VB, that is the higher voltage, VB minus VD divided by I3 is equal to 0. Okay, so are we clear on how did we get this equation? So this is our first equation, and then this is now our second equation. Okay, very good, Mr. Maba. What about the others? Okay, so after having this one, you can now place the values, the corresponding values of those variables. So in here, we have VA is equal to 10 volts, okay, minus VB, so we don't know the value of VB yet, plus, oops, divided by R1. R1 is 10 ohms, okay, plus VC is 20 volts, since that is the voltage that is passing through this VC right here. 20 minus VB, so we still don't know the value of VB. And then R2 is 20 ohms minus VB, so we don't know the value of VB, minus 0 divided by R3 is equal, oops, R3 is 40, okay, is equal to 0. Okay, then after that, you can simplify it further by multiplying the entire equation by 40. Okay, so I'm multiplying this one by 40 since I would like to eliminate the denominators. Okay, so of course, after having this one, so 40 divided by 10 is 4. So 4 times 10 minus VB. Okay, plus. So in here, 40 divided by 20 is 2. So it's multiplied to 2. 2 times 20 minus VB. Okay, minus. So 40 divided by 40 is 1, or it will just simply cancel. So it will retain as VB. VB is equal to 0. Okay, so are we clear on how did we get this equation right here? So I hope you guys can see this one. There you go. Are we good? Were you guys able to follow on how did we get this equation right here? Okay. All right, so the next one that you need to do is, of course, uh, call this one. Hmm, forget the term. Distribute. Okay, you have to distribute this 4 and 2 now. So let me use this text right here para mas readable. 4 times 10 is 40 minus 4 times BB is 4 BB plus 2 times 20 is 40 minus 2 BB minus BB is equal to 0. And then from here, you can now add similar units. Okay, so we have 40 plus 40 is equal to 80. And we have VB minus 4 minus 2 and then minus 1. So it's negative 7. Negative 7 VB is equal to 0. Okay, and then from here, you can now transpose uh, the VB on the other side. 80 is equal to 7 VB. And then you can now have this equation. VB is equal to 80 divided by 7. And 80 divided by 7 is equal to 11.4285 or 43. 11.43 volts. Okay, so we now have the value of VB, which is 11.43. So were you guys able to follow on how did we get this 11.43? Okay, very good. And then from here, we can now actually use this one to get the current on VB, okay, and then so on and so forth. But before that, let me just clarify the question. So in the above circuit, no D, source, and blah, 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 blah. So we have the original circuit. Okay. So our only goal right here is, so there is actually no question. However, our only goal here is to find the current across I3, okay, and then the voltage across VB, okay. So yeah, we already have the VB, and then the only one that we don't know is the I3, okay. Since we already know that the voltage across this one, this node right here is 11.43, so we can now use this one to solve for the I3, okay. So I3 is equal to V3, okay, divided by uh, R3, okay, wherein V3 is equal to VB divided by R3. And then VB is equal to 11.43 divided by R3, which is 40 ohms. So by solving that one, 11.43 divided by 40. So it will give us a result of 0.28575 or 0.29. Okay, so are we clear? And how did we get those two unknowns? Only one. What about the others? Okay, very good. And then the rest are, also super easy. Finding the I1. So the same concept, we have the V1 divided by R1. So V1 is equal to 10 volts divided by R1 is equal to 10 ohms. So we have 1 ampere for the I1. Okay. And then for the I2, so we have the same concept. I2 is equal to V2 divided by R2. Okay. Wherein V2 is equal to, uh, wait, wait a second. V1 is 10 and then R1 is 10. Yeah, that's correct. V2 is equal to VC, which is 20, divided by R2, which is 20, which is also equal to 1 ampere. Hmm. Seems that there is something wrong. 1 ampere, 1 ampere, and then the leaving should be equal to I3. Okay, so this one is incorrect. So for us to be able to get the current right here, so I think we have to find the correct value of VC. So my bad on that one. So for us to be able to get the let's say VA and then the final value of VC, so you have to put this one, okay, as the final value of VB and then retain the unknown. Okay, let's say VA. So just retain that one and then you can now solve for the value of VA. Okay, but I will not do that one anymore since again the our only goal is to solve for the VB and then the I3. Okay, so yeah, I would leave that one to you guys for you to be able to solve the VA and then the VC. And then after that, you can use those values to solve for the unknowns for the I1 and then I2. Okay. All right. So any other questions so far regarding with this one? Okay. So I guess none. So yeah, that's it for the first example. Now let's move on to the second example. So this is not the complete version of what we have in here. So in here we are only solving for the VB and then I3. But in here, let's now try to find the individual currents I1, I2, I3, and then the individual voltage drops VR1, VR2, and then VR3. And then the VA, VB, and then VC. Okay. So in here, again, the same concept. So we have here the KCL at this VB. So we have I1 entering and then I2, which is also entering, and then I3, which is leaving. So that's why it's negative. Okay. So again, how did we know that I1 is entering? Because we have this kind of polarity right here. Okay. So positive, negative. So as we can see, we have the current that's flowing right here for the I1. And then in here, we have a current source. So as usual, wherever is the arrow pointing, that is the flow of current. So in here we have the I2, okay, which is flowing from here to there. So we have entering, and then of course they will meet right here, and then we have a leaving current on the R3 or I3. Okay, so are we clear so far on how did we get this equation right here? Okay, so in here I just transpose the I3 on the right side, so that is why I have now I1 plus I2 is equal to I3. And then the first thing that we need to find is the VB. So same, we have to find the VB and then the IR3. So again, with the use of Ohm's law, I is equal to VR. So we can now find the individual currents, like I1 is equal to V1 divided by R1. And then in here, as you guys can see, for us to be able to get the V1, okay, right here. So we need to find the higher voltage minus the lower voltage. So our higher voltage is the VA, okay, that's 30 volts since there is no voltage drop yet. Then after passing through this R1, we now have a lower voltage which is the VB, okay. So that is the reason why we have here the VB and then divided by R1. So again, just by having this concept, you can now replace the I1 with this 1, and then I2 with this 1, VC minus VB divided by R2. And then the R3 is equal to VB minus VB. Okay? And then after that, you can now place the given values that we have in here. So VA is 30, and then VB, so we don't know that one, so just leave it as it is. And then R1 is 5. So we have here 5 ohms. And then one thing that you will notice is plus 3. So it's already a given current. So we don't need this one as this one is already equal to this value right here. So as you guys can see, we have a current source. So I3 is already solved, which is 3 ampere. Okay. My bad, not I3, it's I2. Okay. I2 is already solved, which is positive 3 amps. And then for the Where is that one? I2. Yeah. And then for the I3, okay, we have here VB minus 0, or to our ground or a reference uh, node, okay, divided by 3, which is the R3. And then after that, we have to eliminate now the denominator for, easier way to solve things. So in here, we have to multiply the entire equation by 15 for us to eliminate those denominators. So 15 divided by 5 is 3. And then 3 times 30 is 90. And then 3 times negative VB is negative 3 VB. And then in here, we have 15 times 3 is 45. And then on the right side equation, we have 15 divided by 3, which is equal to 5, multiplied to VB is 5 VB. So that's how we've got this equation right here. So, question, were you guys able to follow up to this point? Okay, very good, Mr. Maaba and Mr. Donato. Skinaran, very good. What about the others? Can you guys follow? Very good, Mr. Francis, and then Mr. Cameron. Okay, very good, Miss Maris. Okay, so after this, then the following expression are now just done by simplifying this one. Okay, so 90 plus 45 is 135, and then negative 3 VB. So if you're going to transpose this one on the right side, it will give you a result of 8 VB. Okay, so you can now solve for the VB wherein 135 VB is equal to 135 divided by 8. And then just solve this one using your calculator, and then you will get 16.875 volts. And then of course, since you now have the VB, then you can now find the I3. Okay, so we have two ways for this. So I3 is equal to VR3, okay, or VB divided by R3, or you can use the equation itself. Where is that one? This one right here, the equation for the I3. Okay, wherein I1 is this one, and no, sorry, tama ba? Okay, so it's now quite confusing. So let's go over with I1 first, and then let's solve the I3 later on. So for the I1, so you can solve this one using this equation right here, VA minus VB divided by R1. Okay, so VA is equal to 30 volts, and then VB is equal to 16.875, and then R1 is equal to 5. So solving that one in your calculator, it will give you a result of 2.625. Okay, using this equation. Okay, this one only. And then for the I3, you can use this one, VB minus VD divided by R3. Okay, so VB is 16.875, and then VD is equal to 0, and then R3 is equal to 3. So again, using your calculator, you will have this one as your answer, 5.625 ampere. And then for the I2, so you can now use this equation right here. So we have a lot of ways actually. So you can use this one or this equation right here, or you can simply use the Ohm's law rule. I2 is equal to VR2 divided by R2. Okay, so all of them I will give you the same result. Okay, so in here we've used this one wherein I2 is equal to I3 minus I1. So I3 is 5.625, and then I1 is 2.625. And then just solve this one, it will give you a result of 3 ampere for the I2, which is actually already equal to this one. Okay, so 3 ampere, 3 ampere, 3 ampere. So were you guys able to follow for the individual currents for the I1, I3, and then I2? Okay, very good. What about the others? So if ever that you have a question, so just ask it right away. Okay, so don't be shy to ask. And then for the VR1, so we have this method, VR1 is equal to I1 times R1, and then it will give you this result, 13.125, or you can just simply use this equation right here, wherein VA minus VB. So VA is 30 minus VB, which is 16.875, so it will give you 13.125. So are we clear on how did we solve for the VR1? Okay, very good, Mr. Maba. Very good, Mr. Isagani. What about the others? All right, so only 2 out of 12. So if ever that you have a question, so maybe you can message me, okay, just in case you're quite shy to ask it right now. Well, anyway, that's it for the VR1. Let's now move on to the next one, solving for the VR2 and then the VR3. So again, using this formula, I2 times R2 will give you 12 volts for the voltage drop across R2. And then for the VR3, so using this formula, it will give you this one, 16.875. So 5.625 times 3. Okay, so that's the voltage drop across R3. And then, as we all know, VA is 30 and then VB is 16.875. Then we can now solve for the VC. So in here, I just simply retain the variable VC, and then, all the given values will be placed in here. Okay, so in here, we only have one unknown, which is the VC. So you'll have that one as your equation, as your expression. And then what I did next is I multiply the entire equation by 4 because I wanted to eliminate the entire equation. I, I, I would like to eliminate the denominator, okay, for the entire equation. But in here, so this one is already solved, 2.625. And then this one is already solved, which is 5.625. So you can, simplify this one first by simplifying this one or solving this one. With that, you're already eliminating the denominator, which is a 5. So as a result, it gives us a value of 2.625, and then in here we have a 5.625, and then we now only need to eliminate one denominator, which is 4. So that is why I'm multiplying the entire equation by 4. Right? So just multiply this one by 4, and then it will give you as this one as your result. And after that, you can find the VC just by transposing uh, the others on the right side. Okay, so VC is equal to this expression right here, and then it will give you a value of 28.875. Okay, so for the computation, so I'll leave that one to you guys since it's already in here. All you need to do is verify on how did we arrive with this one, how did we arrive with this one, and so on and so forth. Or you can have this equation right here, or this expression. VR2 is equal to I2 times R2. So this one is a lot easier, okay, than having this entire equation. So in here, VR2 is equal to VH minus VL is equal to I2 times R2, okay. And then after that, you can now put the given values for the VB, I2, and then R2, and then you can now find the VC. Okay, so VC is equal to 12 plus 16.875. So just add that one, and then it will give you the same result. Okay, so in here, you have a lot of ways. Just uh, try to verify if you will arrive with the same answer. Then if you arrive with the same answer, then most probably your answer right here is correct. Okay, so with that, we already have the values for the VA, VB, and then VC, and then the VR1, VR2, and then VR3, and then the currents, which is I1, I3, and then I2, which is already given. Okay, so I hope you guys were able to get the idea. So just verify this one later on. And then that's actually it for the example number 2. So generally, nodal voltage analysis is more appropriate when there are a larger number of current sources around. Okay, so if we have a more voltage source, then maybe superposition is a good thing. And then if you have more current source, then nodal voltage analysis is super excellent, since it's basing its expression or equation using the KCL law, okay, or the Kirchhoff's second law. Ah, second law ba yan? First law, rather. Kirchhoff's first law. Okay, and then if you need more examples, so feel free to visit this one. So they are free, so don't be shy to click those links. So it will give you more explanations and of course more examples. Okay, and then of course maybe a different approach on how to solve those individual currents and then individual voltages. Okay, so yeah, that's it for the uh, nodal voltage analysis theorem. So any questions so far regarding with this module? Or if none, then just give me a thumbs up just to let me know that everything is good. Okay, very good. All right, so as early as of now, the coverage of your midterm exam this coming Monday, okay, Monday next week, that would be on 12, so July 12 is your midterm exam. So of course, all of the modules, so from module 1 to module 6. So make sure to review everything, okay? And then how many items? So we're going to have 6 items, if I remember. 6 or 5 items, okay? In your exam. So basically one number each topic, okay? So make sure to review everything. And then for your quiz, supposedly you're going to have a quiz for the, okay, you're going to have a quiz for the nodal voltage analysis and then superposition theorem. But you don't have enough time anymore. And then I would like you guys to have the next meeting as your free time to finish everything, okay, especially in your laboratories. So, and this will be your time to review or to prepare for your coming midterm exam, okay. So I will not give you guys quiz for those last 2 modules. So in here, just try to solve a lot of examples, okay, given in here for the practice exercises. And yeah, so that's it. And then don't forget to answer this one also, this case study number 3. So the due date of this one is July 12th. All right. So yeah, that's it. Any questions so far, guys, or clarification? Okay, so if none, so just give me thumbs up and then you may now go. And then let's just meet again after your midterm exam. Good luck and thank you guys for attending our class for today. Okay, so thank you and goodbye.